Oh, I want to talk about how I was able to create a digital twin of the state of Utah in the United States. And using my internal DSL system and taxonomy system, I was able to actually digitize the entire state. So I use a codex that I've invented. And let's say, for an example, let's see, the Department of Utah State Operations. And as you can see right here, we have like different filters. Oops, scroll down there. Over all. But then they can compress or whatever. But each one of these are digital offices, right? So these digital offices have an ID system that I was able to apply to any state, any county, any city, any vendor, any individual, any object. And the way these sequence numbers work is basically a way it's an identifier. And I use a leverage of a multitude of different, let's just say, every state has an ID and every state has a generation number. And I'll have to explain all this stuff later, but for the case examples of what I've done is I've created digital asset registries, terminal registries, and to be synced with the state, county, and city operations, because I was able to actually digital twin their operations inside my ecosystem. And the same thing goes for county departments, right? And even state sub-departments. So every state department has either a division, and inside that division, I'm able to construct and know exactly where these ecosystems, well, where these offices are in the ecosystem with precision. So much precision that I know I could, well, how do I want to define this? Because there's so much information to share. I'm going to move that for another topic. Let's just put it like this. It's like in a real-time audit. Let's see. So this is the county departments. And again, I was able to digital twin this state of Utah in 2 days. And that was with me developing like 4 other apps while I was doing other stuff. So, I mean, I could go faster. But it just goes to show you how fast I can actually like carbon copy the entire planet, or I would say the country, and then put that into my ecosystem so then we can then turn this thing on. Now, what do you mean turn it on? So I have protocols that are basically its own ecosystem network. And in this network, I'm able to send information to and from our nodes. So very kind of similar to what blockchain was trying to do. I actually just did it. Like I was able to do it, dude. Because I can onboard any asset you can imagine, right? So in my network, we can transact with these digital offices. Okay, so let's say these digital offices have, let's see, well, let's see. I got so many things going on here. Tokenization, onboarding, there it is. So for an onboarding form, so I created like 25 different asset classes. So residential real estate, commercial real estate, and so forth, right? So let's just say residential. So the way we can onboard assets, let's just say it's an individual that wants to onboard, and then, so let's just say this asset's being onboarded, where this is linked, this form, it keeps going, it's linked to real world forms that are, considered protocol for you if you're going to buy a house. Well, in the system, it's onboarding that into a digital container. That digital container is sitting inside of a SOAP, which has a SOAP ID number, which is sitting inside a TTR, which is a Toolbox Terminal Registry number. And then it gets assigned a digital registered asset number. And then anytime that digital registered asset's moving around in the ecosystem, right? Anytime it's moving around in here, it's being tracked. Let's see. It's being tracked through the registry. it's being tracked through here, right? So this is the digital asset registry. So think of this like the central bank of data transfers, right? So we're calculating if this digital asset exists, we're going to audit that in real time, okay? And let's say you want to transfer it. If you're going to transfer it, you can transfer it from one person to the next, or a city to a city, or whatever the case may be, a vendor to a vendor, so forth and whatnot. And I'm able to, let's see, digital registered asset. So let's say the digital asset itself will actually contain within it a digital office. That digital office will contain its value. It will contain the asset specification timeline of like, kind of like the assets timeline, right? And then the asset's value over time, okay? And then any type of documentation that was supporting that documentation, which is, this is a residential property. And it's basically a digital office that's following that digital asset as it exists, right? From maintenance, inspection logs to asset detail overview, transactions, and then basically, in short, we're tracking all this information in our network. So anytime this asset is transferred to another owner, they basically acquire the office of that asset, okay? Which makes auditing so much easier. And it's ultimately done through my classification system, which is a taxonomy system that I've invented years ago. So for the record, when I invented this before OpenAI was like a thing. I shelved it for years because it just wasn't time. I didn't think the world was really ready for a solution. So it was kind of like not really important. But nonetheless, the reality remains is that this is sitting at a time to share. Because I have all this stuff. And I can finish packaging this stuff up relatively quick, but I've created all this. I had to end up creating like a domain-specific language, a taxonomy system, a tokenization language, and then I had to create the domain-specific language is by far the most comprehensive challenge for me when I was inventing it a while back ago. Where are we at here with that? I know I've got it somewhere around here. I want to show it. Dun dun dun, tokenization. Oh, there it is. DSL. So this is a domain-specific language that I just straight up invented. Had to. So it's written in Rust and Elixir, and it's basically a constitutional execution language that adheres to all these rules that I had to create to determine how to communicate with the ecosystem of parts that I had to create. So it starts getting like, let's just put it like this. It transforms the way computers can communicate with infrastructure. So for example, being that I'm able to digitize and being that I'm able to taxonomize and digital twin the entire anything I want, tangible assets, intangible assets, even the capacity to then, once I've digital twinned them, I'm then able to create a digital office inside of them, which I didn't show you the interface to the office, which is actually my pride and joy. I'm not going to share it with you though, because it's so cool. It's way cooler than all this stuff, but because it's the office that's embedded inside this entire ecosystem, and everybody would have access to a digital office. That digital office would allow you to plug in Claude Code or AI agents, and it could be part of the infrastructure of our society and play part into functions. Because function terminals, which is something that is really part of the ecosystem of parts, which is actually, where is that? There's a function terminal right here. So this is like a function terminal. So this is how like function terminals work in reality. So like we all know what, like, well, this is going to get into a long video. Not enough time. Not enough time. But dude, it works. It's so legit. I'm able to like create not just smart contracts. Imagine a smart contract with a real office that you can plug AI agents in and actually run part of society. And not only just link directly into society, but I can do way much more than that. But all this is a containerization process, right? So like every continent that exists to every country, state, city, I'm able to containerize all that stuff. Not only just taxonomize a asset, I go 17 steps above. I can containerize an entire economy. So if there's infrastructure, I can tokenize infrastructure. I can tokenize an entire vertical industry or horizontal industry, because sometimes a vertical industry in itself is value, and we haven't really thought about value, and I'm able to tokenize those things if we ever desired. But and the way I've done it is I've centrally distributed the ecosystem to have the ability to interconnect into any digital twin aspect that society currently possesses. That is where I stand at a way different pillar of how this stuff works. So we have like every registry I've created, well, let's just say it like this. Everything I've created is part of a unique system. Well, it's like a unique ecosystem of parts that are defined to create a language amongst itself that any developer could link through. Like right now I have 3 interface deployments that I'm going to work on, where I'll have like a VS Code plugin, a CLI, which is going to be great for just like AI integrations, and then a SDK, right? Because then I can like package out deployments. Any user could work on this stuff, and the reasoning why is that most users know what a PDF is. Well, a lot of the stuff that I've done is simplify it to where I can take a normal operation of a city or a state or a county, convert a lot of their paper transitions, move them into these digital transitions, and then we can then begin to onboard real world assets into an ecosystem that has way better audit tractions for federal, state, county, city infrastructure, because we've digital twinned the offices to sync directly to where they're actually located in the real world, because they'll actually have what you would call parameter access to that. And that is where this whole thing starts to become just way more effective than anything else that's on the market.